Welcome everyone to today's webinar, Enhancing Oracle Autonomous Database and Autonomous Health Framework with GenAI. My name is Nikki, and I'm a Marketing Event Manager for the Developer Initiative here at Oracle. And today we're excited to explore how Oracle integrates GenAI into its services. If you have any questions, please drop them in the Q&A and they'll help us identify those unanswered questions. We've also set up a Slack channel, Oracle AI ML services in our developer workspace that you can access at the QR code or the link on the screen. This channel remains open after the webinar for you to contact us directly whenever you have any questions. And before I pass it off to the presenters, I wanted to let you know we have more amazing events just like this one coming up. You can either check them out with a QR code or with a link in the chat, which I'll share in a little bit. And today's webinar will be presented by Herman and Arjun. Without further ado, I'll pass it to Herman.
Okay, all right. So great, another Gen AI session. This is very exciting for me. I love this, AI related session. So we are here today because we wanted to show you how we are leveraging Gen AI in multiple Oracle services, and specifically, we are part of two teams: Autonomous Database and Autonomous Health Framework, and we wanted to show you some of the innovations that we've done in the context of these services. So with me is Arjun Update today, a consultant member of technical staff in the AHF team, and I am Herman Viscuso, and I run the developer community in Autonomous Database. Okay, so without further ado, let's just do some intro here. Before that, say Harvard's statement. We are talking about some things that are not available yet as part of these services, especially in the Autonomous Health Framework side. So bear with us. This is coming, and we're working very hard to bring you a top-notch Gen AI-based service. Okay, so a little bit let's take a look at the agenda. Okay, so we will take a look at how we are leveraging AI at Oracle, at least at the high level introduction to that. Some Gen AI specific use cases where we think this specific technology is making a dent and it's becoming very, very, very interesting. Then we will take a look at the Autonomous Health Framework and how they are leveraging all this technology to drive a diagnostic assistant solution. We will take a look at the solution itself, the architecture. We'll take a look at the demo that Arjun will be showing, how they are supporting all the different workflows, how they are working in a mixed environment where they have NLU but also an LLM based solution, which I think is very, very interesting. And then I will just close the session with SelectAI, and hopefully, if there's which is a technology that allows you to basically use natural language to pass SQL queries to the database. And I hope we have enough time to go through a very quick and short demo for SelectAI. Okay. All right. So what do businesses need to be successful, right? So effective use of data is something critical for business success. And effective use of data has been irremediably, I would say, affected by automation and AI. So we won't be looking back at the pre-AI data management. So from now on, automation and AI will be more and more important, and this is why we're having this sort of sessions with you. So the latest AI advancements are so pervasive that we are incorporating its advantages at every layer at Oracle, as you can see here. We're not only taking we are not only talking about AI enhanced services to improve the customer experience, which is a very, very important part, but also to provide great support for AI workloads in the cloud and to leverage AI for internal tools. This is very, very important to us because it's not only about customer-facing advancements, but also how we use AI internally in our own services to improve operations. So examples of infrastructural all the enhancements that we have in Exadata itself. Remember that we released the 24 AI software for Exadata that comes with a lot of AI-based advancements. And for data platforms, obviously our best database services are now supporting Oracle Database 23 AI. This is the Oracle database on steroids for the new era of AI. and also multiple tools and services that are catering to supporting not only AI-based workloads and data science in the cloud, but also your applications. So we want these services to allow you to build the next generation of AI-based applications. So let's take a closer look. We are bringing AI at every layer, as I mentioned before. Okay, so here you can see that we have at the bottom right, have Cloud Plus NVIDIA to train the foundation of GenAI models. Supporting workloads is very, very important, all the training, et cetera, et cetera. Then we have enterprise data management. Now take a look at the, let's say, the third column or fourth column, data integration, data management. We have enterprise data management and privacy security know-how that allows you to manage the risk associated with this technology. Very, very important, especially if we're talking about mission critical workloads, et cetera, et cetera. We have an application stack that where the knowledge workers living, where we are embedding GenAI technology to radically transform the productivity. And there we are talking about, assistance and productivity affecting GenAI technologies. But we are also focusing a lot on the route that you see there that says AI services in green, because we now have platform services, just like we use them at Oracle. You can build your own enterprise-grade GenAI applications into your business and into your products by leveraging, pre-made solutions like anomaly detection, digital assistant, speech, language, vision, et cetera, et cetera. Okay. So let's take a closer look at services. So we're talking about cloud services here. Yeah, you might be familiar with the Oracle Cloud Infrastructure already, and we are leveraging AI to accelerate time to value. This is, an add-on to the services that we have, and we are doing this across multiple services where we want to leverage GenAI. So it's easier for you to ask, to create, to summarize, to personalize the service, to create dashboards automatically, to monitor your applications with assistance from AI-based technologies. So we want you to be able to interact with services using natural language. We want you to be able to build your extensions or custom parts of the service with AI's help. So this is happening, as I said, across tons of services at Oracle, and it's a real revolution. This is not just hype. This is really happening, and it's basically becoming a big change at Oracle, and I would say, across all vendors. So this is, for example, an event with Michael and Andy that is open for registration with GenAI, where GenAI is used to power low-code generation in Apex. You might be familiar with Apex. It's our low-code technology. It's very easy to set up, to create an application based on Apex and autonomous database, practically without being a developer, to put it some way. So if you're interested about how GenAI is being leveraged in this type of services, just join. There's a link there. Join the session and be ready to hear about something similar to what we're presenting right now. Right? So there are so many use cases. I don't want to go through all of them, right? But we have, for example, customers operations in the first column, where we have automated customer service, and we have assistants like we will see with the AHF diagnostic assistants in a minute. Marketing and sales for content generation, mass personalization, etc. Understanding the buyer profile, usage history, etc., etc. So I don't want to basically go through all of this. We will be sharing the deck later. So now let me introduce Arjun Apade, a consulting member of technical staff in the AHF team that will show us the diagnostic assistance in AHF, Autonomous Health Framework. Okay.
So today I would be taking you through a diagnostic assistant, which helps support engineers and DevOps engineer interact with the diagnostic data in a natural language format. And we would actually go into the variety of the data points that we actually care about from diagnostic perspective. AHF, which is the Autonomous Health Framework, is actually responsible for capturing diagnostic at various layers of the Oracle stack. And we would be making use of the diagnostic assistant to help triage issues. So just a bit of background from AHF perspective. The Autonomous Health Framework is an AI ops platform which is responsible for various different aspects of diagnostics and monitoring. We have capabilities for monitoring, observation, and collection of the relevant diagnostic data in real-time and non-real-time fashion. We have the ability to actually capture only contextual bits that are required in order to resolve any issues. There are aspects which help automate the health checks of the system, identify the anomalies in the system, whether it is related to database, whether it's related to underlying layers of the Exadata. Various different parts of the stack, we are able to identify the issues and come to a conclusion regarding what is the root cause of the issues. We also have an aspect which engages with the right personas. So if there are support folks or DevOps engineers across a variety of teams in the organization, we also engage with them by creation of automatic service tickets and making sure that they are notified regarding those aspects, and also take care of the cleansing of the data if it has any sensitive information within it. So with that, we would actually jump onto the variety of the data points that we would be using as part of the diagnostic assistant later on. So I just wanted to make you aware about the kind of data that we are dealing with. This is a high-level fleet information from one of our internal test fleet. And here what you would be able to see is there are various different dimensions of diagnostics that are being captured: high-level topological information, configuration information, issues that are happening across the fleet. You would be able to see those things real time. Moreover, you would also be able to slice and dice this information from a variety of perspectives. So on the right, you are able to see information regarding events being sliced and diced so that the manager who's looking into the fleet would be able to take appropriate actions in order to make sure that the fleet is running in a smooth fashion. We have information regarding best practices, whether Oracle best practices are being followed across the fleet. And if there are violations, those violations get bubbled up as part of these dashboards and help the fleet manager make sure that appropriate actions are taken in order to resolve those best practice violations. When we drill down on information from fleet level to a cluster level, we would be able to see information from AHF Insights. AHF Insights is a product which is already available to the Oracle database customers as part of the database image itself. So you would be able to actually generate the AHF Insights report on your database systems. What it provides is, it provides you a bird's eye view of the system for a specific period. And during that period, if there are various different kinds of issues or observations that are made by the AHF stack, it kind of brings those things in the forefront through the AHF Insights report. Here you would be able to see a variety of different events that have happened on the system, if there are changes that are happening on the system from a configuration point of view, if there are operating system-based issues that are showing up, if performance issues related to databases are showing up. All that information is actually brought to you together within the Insights report. Here, the idea behind showing all these details is to make you aware of the kind of data that we are dealing with, because that is going to be quite vital when we go into the diagnostic assistant part of the presentation. So here you see a variety of events happening across the system. Since it's a clustered system, we would want to have different perspectives across the cluster, drilling down into specific nodes and things like those. So all these variety of structured information is something that we are capturing as part of AHF. There are a variety of metric information that we capture as well, and you would see information regarding annotations for the anomalies that have been detected on from these metrics. These information cuts across CPU, memory, network, I/O, process, and all the various layers of the stack. We also perform anomaly detection for all these metrics and kind of correlate them at higher level to come to a root cause analysis and bringing a picture forward regarding what had happened on the system, so that the person who's actually triaging the issue or working on resolving the issue has a better idea and can save time. There are also aspects regarding identification of the softwares, whether they are out of date, if there are some patches that are required to be made, various configuration informations like RPM, kernels, and all those details are captured as part of EHF as well. So with that, we already know about the kind of data that we are dealing with, and we would jump on to the challenges that a support engineer would face. So in a generic fashion, the support engineer would face issues for delays in information retrieval. So if there's large amount of diagnostics that's being collected, like large amount of logs and traces and a lot of information, which is ranging across longer time periods, identifying issues there is a needle in a haystack problem. And even if you identify issue at individual dimensions of diagnostics, still getting the right bits together becomes a challenge for triaging and debugging. Then there are various aspects that a support engineer needs to perform. There are various operations that they need to perform, and many of those tasks are repeat tasks, but they have to be done manually, which can be significantly automated. Then we have high volume support tickets that the support engineers are responsible for, and they are under pressure to actually make sure that they are able to close many of them as soon as possible because it impacts customer satisfaction. The other aspect of the support issues are information overload, because when they are resolving issues, they need to be quite up to date regarding the product. The products are quite complex and well integrated. So they need to be on the top of their game in order to resolve any issues from various different configurations for various different versions and various different products. And if there is some misrepresentation of or misinterpretation of the logs or traces, they might provide wrong troubleshooting step, which would backfire. The other important aspect, which is a challenge for support engineers, is the information silos and navigation issues. So if there are multiple different services wherein the information is being siloed, if there are the bug repositories, if there are service ticket repositories, and if there are various different services wherein diagnostic data is scattered, then for every application in your organization, you would have to interact with different applications, learn the navigation bits across all those applications, and need to be updated regarding how to find the right set of information when you are trying to resolve the issue. And here, getting issues resolved as fast as possible is the goal. So if you look at a support engineer, they generally need specific set of information when they are focusing to troubleshoot a given issue. They might ask for, what were the major events that are happening at a specific point in time? What was the last time a given patch was applied? Then they might have some product specific question as in, what's the node eviction issue? Let me just get myself up to date regarding the issue at hand so that I can look at the right set of information in order to perform the resolution, right? If there are some slow queries, like is my system having slow queries? Are there database performance issues? They might have, they have these kind of questions that they have to figure out from the diagnostic that have been captured. Moreover, if the questions go across on the product lane, then they would have to scan through a variety of knowledge management nodes and Oracle database and documentation nodes for different versions to figure out that information. And just the information retrieval takes up a lot of time for them. So what we have devised, we have implemented is a diagnostic assistant, and it's an AI chatbot which provides a natural language interface. So with this assistant, you would be able to actually get the information that you need on demand. As in the support person or DevOps person would be able to bring that in, request that information and get the information on demand. It helps make the support person's troubleshooting simpler and faster. So there are various different techniques that we are using as part of this solution. So we are making use of the intent classification aspect from the natural language understanding space, which helps associate for a given natural language query, what's the API we would want to call. We also leverage entity recognition, which kind of gives you details regarding what are important terms and phrases that have associated context to it. So if we want to figure out if there is a host name which is mentioned, if there are metrics like CPU or memory, those things are mentioned, we would be able to kind of identify those things because they would act as parameters to the APIs that are being called. Then we leverage the retrieval augmented generation through the large language model pipeline, essentially making sure that all the natural language information that's stored in the knowledge base or in the documentation or in the SOPs, we are able to leverage those things also on demand. And all this techniques we are applying on the structured data that we are collecting as part of the HF stack. We also integrate with a variety of different internal services that helps users get information from a single point, even though they are siloed in different services. And then there are aspects of automating certain workflows depending on the kind of persona. If there's a support person looking at the information, there are certain sequence of information that they would be looking for. If it's a developer who's looking for the information, they might want to look for certain other set of details which are more from the debugging aspects. So with the diagnostic assistant, what we would be able to do is the questions that generally the support engineer would ask, we would be able to provide on-demand responses. So if the question belongs to the space of diagnostics, we would be able to bring the right set of event or the right set of anomalies that are identified for a given period. And if the question belongs to the space of from the documentation or the SOPs, we would be able to actually bring out a summarized natural language response, which would be easier for the support person to understand right away rather than scanning through various different documentation pages or SOP pages. So at a higher level, the architecture is quite simple. We have a user, which is the support engineer, who would make use of a web application or a desktop application to interact with the system. They would provide the natural language query through the interface, and it goes to this pipeline of intent classification and entity extraction first, wherein we are able to identify what are the intents that are mapped with higher confidence. If the intents are mapped with higher confidence, we actually leverage the API calls to the various services and the diagnostic data source API that we have as part of the HF data repository, and provide that information directly to the user. And if there are intents which are mapped at lower confidence, that means we do not have an API corresponding to the natural language question that the user is asking for. It goes through the RAG route, wherein the whole RAG pipeline is at play. We use Oracle Vector Database, the 23AI database, in order to save the vector information, the embedding information, and leverage Cohere as our large language model. We also provide additional, there's a support for additional features that can be provided for a desktop application because it would be natively sitting on your dock, and that helps provide many of the alerting and notification related services as well as pre-configured workflows. So here I'd want to spend a little bit of time explaining the benefits of having a synergy between the NLU techniques and the LLM techniques together. So from a natural language understanding perspective, like the intent classification as well as entity recognition, we are able to provide repeatable results. So the hallucination problem that we have from an LLM perspective, if the support person is asking for questions regarding diagnostics, it better not hallucinate, right? So we are able to provide repeatable results using the intent classification as well as entity recognition. And we are also able to provide structured responses using this method because there is an API underneath. In order to perform these operations, the intent classification as well as entity recognition operations, they are quite cheaper as compared to the large language models, right? But the disadvantages from the intent classification perspective is we are not able to provide responses for everything. If it belongs to a natural language space, wherein there's a large amount of natural language information which requires a semantic understanding of the content, the NLU techniques for intent and entity recognition would not be able to fare well as compared to the large language models there. And from the large language model perspective, the advantages are we are able to actually employ the RAG pipelines to make sure we are able to bring in a lot of these documentation and knowledge management information upfront as a on-demand response to the user. But the disadvantages there are that we would not be able to provide like repeatable results as what we provide as part of the APIs. But and the other aspect is they are relatively costlier as compared to the intent recognition as well as intent identification as well as entity recognition techniques. So both of these in synergy works quite well because they take care of each other's advantages and disadvantages. So with that, I would want to jump on to the support user workflow. This is an example of a support engineer when they are trying to resolve an issue. So the support engineer would request for the right set of information, and then they would get that information on demand using an intent response. And if the question belongs to the space which is outside the diagnostic space, the RAG pipeline from RAG pipeline and LLM would actually come to play and would be able to provide the relevant responses. We would look into these things in much more detail in the demo. So here you are able to see conversational workflow wherein the user is asking questions and getting responses for those questions on demand, and they do not have to leave the platform. So with all these questions that we are asking, we would also be able to send out structured responses since intent recognition is at play, and the APIs would be able to provide structured responses in the form of various graphs and charts, which the natural language, which purely LLM would want to be able to provide, but the combination of LLM as well as the intent recognition like serves us quite well in this particular area. So with that, we would want to jump on to the demo. So I have the Echelon client on my dock. And with that, we would go into the same use case. So this is the Echelon interface, which is a chat-like interface, which provides you a way to interact with various different diagnostic data sources. So the user would ask, what's the issue that has happened on the particular in the particular bug, and we would be able to make a call to the API, understanding the bug description and classifying them. So here the problem is related to node eviction, and we get details regarding the time at which the node eviction issue happened, on which node it happened, etc. So it's an intent-based response. Now, if the user wants to understand what the node eviction issue is and wants to get themselves up to date on the concepts, then they would be able to ask those natural language questions as well and get a more detailed understanding on what aspects it touches. So if there is issues related to network failure, disk failures, I/O issues, or memory pressure issues, they would be able to get themselves up to date regarding the problems or the areas in which it can go. So depending on that understanding, the user asks for a subsequent question regarding at the following point in time, which was available as part of the bug description. What were the events that were happening from alert log perspective, and they'll get the structured response. And if there were events around it, they can ask for version information, and they can also ask for information like around a particular time, were there any operating system issues that were observed? And the system would actually bring this information up front by bringing forth all the anomalies that were detected from an operating system perspective, given the following time frame. And these timeframes are something that we are able to recognize using entities. So looking on this response, the user would be able to conclude that the issues are happening because most of the issues are falling into the realm of the memory pressure issues. So then there's a likely chance that the node eviction has happened because of memory pressure. They can ask further questions to satisfy their need that the other options are also kind of taken care of. And this is how they would be able to actually ask individual questions subsequently to the application and get responses, regardless of whether the response requires information from the structured diagnostic data source or they require response from documentation or knowledge nodes. With that, I would jump onto the presentation once again. And just to give an idea that whenever you are asking a question, there is an intent that is getting mapped in the background. And if the scoring is higher, we are able to actually bring in, make a call to the appropriate intent right away. And if it falls into the area wherein the intent mapping does not fall through, then the questions are actually sent out to the RAG pipeline. Just a little more description regarding the internals of how, at a higher level, how things are implemented. So we have an intent classifier, wherein we actually take in large amount of data associated with a natural language question and an API associated with it. So it's a supervised problem wherein we are actually making use of sentence transformer to actually convert the natural language query into vectors, and then fitting the logistic regression classifier. This is a classical machine learning technique in order to perform classification. In this particular case, we are doing multi-class classification. The models are saved in a pickle file, and then the model is reused at the inference time, wherein the new natural language query, when comes from the user, it goes through the same transformer, goes through the model, and is able to provide the result right away. The standard confusion matrix mechanism in order to perform the evaluation of how the intent classifier is doing gives us an idea regarding the ones which are classified correctly, and if there are misclassifications that are happening, that helps us understand and evaluate and improvise our model better. There are mechanisms for intent testing as well as training, wherein the user would be able to ask any new question which might not be part of the training set, and test out what API it maps to or whether it routes to an LLM. We have mechanisms for taking feedback from the user. So if the user is not satisfied with the response, they would be able to provide like more details which can help us tune our intent model as well as the large language model responses. If the RAG pipeline is not providing responses expected, then we'd be able to capture those responses as well. With that, I would want to share the details regarding the underlying RAG pipeline that we are using, wherein we have a corpus of documents which lies in the realm of the documentation, from knowledge management logs, from the SOPs that we would have internally. And those documents are pre-processed, chunked, embedded and saved into the Oracle 23AI database. And then that would be the part of the data ingestion. And whenever we are building the queries, we would actually take the natural language query from the user, pass it to the same embedding model, search for the relevant chunks that match, and augment those chunks with the actual prompt that was provided by the user to send it to LLM to get the natural language response. A variation that we have done, which would be useful for you guys to know, is we would also be able to actually make use of the structured data that we have as part of AHF, in AHF Insights and Fleet Insights. We can leverage those structured data by converting those JSONs into a natural language format in a templatized format, and use these newly generated custom documents in order to ask questions regarding the information at hand. Like, so if the user is asking a more complex question wherein there's no API that is associated with it, still this document is something that can be utilized in order to provide a response, which is more of a which is relatively more complex. But since the large language models are able to understand the semantics of the terms much better, we make sure that there is a vocabulary expansion that happens when we are generating this custom diagnostic documents. So the response is coming from the LLM. By taking into consideration these custom documents, they will be able to provide much better response. With that, I would invite Herman to continue the next part of the presentation.
Right. So let's talk about SelectAI in autonomous database. We're going to take a look at something similar, but something that you can use today to send SQL, to use natural languages to send SQL queries to autonomous database. All right. So let me move forward. First of all, very quick presentation of autonomous database. For those of you that are not familiar with autonomous, it's a fully managed database service with lots of automation and a pay-per-use model with built-in machine learning. capabilities, and without losing all the power and the features of the Oracle database. For example, we announced 23AI support on autonomous database dedicated just a few days ago. And so you can go and deploy ADB based on 23AI right now, right? So it's basically the Oracle database, but with a whole lot more on top, thanks to AI. All right, so autonomous database SelectAI. So it's the simplest way to pass queries to the database. You use your language to query the data. You don't need to understand where the data is coming from. You don't need to create any mappings or anything like that. You just take advantage of natural language, and you get your results back, or you get the SQL. We'll take a look at that. You can use whatever language you want, English, French, Tagalog, whatever, to get the answer. So you don't need to know the structure of the data and how to query the data. Okay, so basically it can be easier. You just ask your question, and then ADB will then manage the entire query process to get that answer. And this includes connecting to a large learning model, engineering a prompt that's optimized for Oracle database sources, and delivering to the app either a result set or a narrative or just a SQL. Okay, we have a sample app called Chat ADB that you can go ahead and try, and it's right there. You have a link at the bottom of the slide. It's built with Apex, which I mentioned before. You know, I mentioned that there was a session coming related to GenAI in Apex, so it's using Apex and SelectAI with autonomous database. Okay, so you can go ahead and try this live lab. It's very easy. All right, so we also see that this could be very interesting for mobile applications where you can get the answer for when you are on the move. Suppose that you are on the move, you're not going to craft a complex SQL query in your phone, right? So basically you can send a specific question related to your database and you will get the result right away. So this is the Chat ADB. It's also responsive design. It also works in mobile, all right? So when you develop with apps with SelectAI, basically you're going for a simple solution. It's because this is very simple to implement. You can take a look at the source code. If you take a look at Chat ADB, you can see how it was implemented. There's not a lot that you have to do as a developer on your side. It's basically interfacing with the LLM service and interfacing with the database, and that's it. It's future enabled because we allow you to select your LLM provider. You can pick the model that is best suited for your business. So you can have a very specific model that works great for your domain, and you can use that one. And it's very secure because you rely on the same Oracle database security because this is running within the database, right? So it's basically all the security that you get in the database, you get with this technology. It already comes with ADB, so you don't have to install anything on top. Basically, the service provides you SelectAI. And if you're using, for example, one of those providers is OCI generative AI, all your data doesn't have to be sent to an external LLM provider, so you stay within OCI, and you don't need to basically send data outside or send a query outside or anything like that. All right, so it's up to you. Okay, so why it has been so difficult to translate natural language to more specific actions, right? Like, for example, a SQL query, to give you an example. So what is it so difficult, or what was so difficult? Because nowadays it's not so difficult anymore, right? With LLMs. So the difficulty was context, right? So GenAI machines got so much better at doing inference, deriving context, that the interactions have become very natural. Here, there are a lot of things that you need to understand context in order to say, you know, oh, this is what this person wants. Like, for example, if I say this month, and I don't know what date it is today, I have no context. There's no way I can derive that, right? So there's current LLMs and GenAI technologies are providing very powerful context matching happening behind the curtains. So all of this is happening for you behind the curtains. And questions like this, for example, are the way we talk, right? But if you consider these mappings here, like total streams is mapping to a total number of movie views, For each is mapping to a breakout views by movie. So here, just to give you some context, we are talking about a demo that we have called Movie Stream, which is like a toy Netflix, to put it some way, where you have movies and you're streaming movies and you interact with the service and you want to know what are the top streamed movies, what actors are acting in specific movies. So that kind of database, right, to give you an idea. So this is how we are passing specific queries to that database. So we would ask something like, what are our total streams for each Tom Hanks movie this month, as maybe a manager of the service, but you will never say, what are our total number of movie views? You break the views out by movies, and then the actor is Tom Hanks, and then I want to do it from this date to this day to this day, right? Basically, you are not going to talk like that. You're going to say the phrase that you have there on top, right? So this is what SelectAI is providing. It is providing a way to map your natural language query, which needs context derivation, right, to a select statement. So here we have what SelectAI would do for you for that specific type of question, where the select will be created. The columns, the tables, etc., will be selected automatically for you, okay? So you don't have to say, oh, this is the table, oh, this is the column, okay? And you can see that the actor is being matched, the time frame for this month is being matched, the group by is being matched, everything is done automatically for you. And also the fact that the total streams are in the total stream column is being basically derived from you automatically. Okay, this is very, very powerful, as you can see. So how do I use it, right? If you go ahead and deploy an autonomous database today, and you're passing a query to autonomous database, you can say select, and instead of going with a typical select with SQL, you use SelectAI. And when you use SelectAI, you're signaling the SQL system that a natural language query comes next, right? So you can do SelectAI, and you can say, what are our top 10 stream movies released after 2010? And that's it. The system will get that natural language text, which feels a little bit weird because you don't even need quotes there. And basically we'll pass this to the LLM. The LLM will generate the SQL for you. You get the SQL back. The SQL, you can get it straight if you want to use the SQL, or you can get the result set if you want to run the SQL. If you use show SQL, as you can see here in the screen capture, you will get the SQL instead of the result set, okay? Very, very, very powerful. Okay, so, I just use SelectAI, pass my natural language query, and then I'm up and running. No, you have to configure this. Why? Because you have to tell the system or SelectAI what is the LLM that you're going to use, and what are the tables or the schemas or the views that you want to use, right? Because the system will basically rely on that to basically find the right columns, find the right tables, etc., etc. Okay, so you choose an LLM as part of the configuration setting. You can choose Cohere, OpenAI, Azure OpenAI. We can use our own OCI generative AI, and then as part of that, let's say configuration, you pass a list of the schemas or tables and connection information. You can say, okay, this are my finance tables, etc., etc. So you're basically passing a reference to the data and how the data is structured, okay? So the process works more or less like this. This that I mentioned, where you define what the LLM is and what the tables are, the views, etc., is called the AI profile, which is the first item there. So you define the AI profile. That includes database metadata, as I mentioned before, and the LLM to use. Then you produce a prompt. So this is all done automatically. The prompt is produced for you, basically uses the profile and the question to pass a prompt. This could be, find the top 3 customer segments for George Clooney movies. There's a process of generation of the SQL using the LLM. The LLM is pluggable, as I said. So there's a back and forth using REST APIs with the LLM to basically generate the SQL. And then you can get the query back you can get the result set. For example, once you get the SQL, we can run that SQL for you, or you can get the SQL and you might want to just run it later or something like that, depending on your application, what you want to do. Okay. So let's take a look at the very short top level demo. This is only 2 minutes. Okay, it's a recording, and this is ChatADV in action, which is the application that I built on Apex that I mentioned before, that you can go ahead and you can run yourself and you can create yourself if you follow the live labs. So let's take a look. I will be pausing and doing some explanations here. Okay. Okay. So as I mentioned before, Movie Stream, right? Movie Stream is the demo application where you have all the movies being streamed, you know, the actors, etc. So it's a big database with actors, movies, you know, streams, etc. So the Apex ChatADV is using that database. So when you deploy it, you just start asking questions. Here is what are the top 10 customers, what are the top 10 movies streamed by number of streams, and you get the result, okay? So, sorry about that, just 1 sec. Let me go back. Okay. So after that, you get the result, and then you say, okay, who starred in the Avengers Endgame? And that's a direct question that you're sending to the system. So the system is processing the question, is connecting to the LLM, bringing the results back, and basically actors, you know, for that movie. And as you can see, Stan Lee was there as an actor, but there also you have a list of Paul Rudd there. And you might think, you know, oh, I heard of Paul Rudd. What else is he known for? So you can send a question here, you know, and all the context is kept. Tell me about Paul Rudd. And here you're basically getting text, you know, that explaining who he is, etc. Okay, and now I want to see, tell me movies where we have Paul Rudd or, for example, Stan Lee. And this is another question that you're sending, also being translated into SQL and getting a result. So these are all being fetched from the movie stream database, okay? Classic movies, right? Being fetched from the table where it has all the movies, and there's basically a, you know, a join with the actors in order to see who's acting there, and this is happening automatically. So that's the full movie list, okay? And now something interesting that I wanted to show you is, for example, how popular are these movies with our customers? Like, for example, show me, you know, how our customers are streaming these movies that I'm interested in related to, you know, Paul Rudd and Stan Lee. So you get the result and you get total streams. But there, if you saw that, we are clicking on Explore. Take a look. When we click on Explore, what we can do, we can go and we can take a look at the result set. And then we can start applying, you know, ordering, filtering, etc., etc. There's a lot that you can do once you get the result set there. Slice, dice, filter, graph, etc., etc. So here are a lot of actions, formatting, etc., etc. You might create a filter there where you say, okay, tell me the ones that have been streamed more than 10,000 times, right? Or show me a graph of those movies that have been streamed for more than 10,000 times. And you're here creating a graph with the most popular stream movies, okay? So you always have that prompt, and you can click on SQL. Sorry about that, you can click on SQL instead of Explore right there, you know, and you can get the SQL. And when you get the SQL, you can see that the SQL can be quite complex. So it's good that you did not have to write it, because you never wrote any of this SQL to explore all this data and the result sets, etc., etc. So this is the power of SelectAI. Okay. So let's wrap it up. What are the good things of generative AI models? What are the bad things? So the results from GenAI models can be very, very good. Also, sometimes can be very bad, but in general can be very, very good, depending on some variables. The systems can be very creative, can create content for you. They can use a specific voice, like, you know, specific to your audience, depending on the type of LLM that you're using. They can capture the attention using personalized messages. So very customizable to specific interactions and very effective in most most of the time, right? What are the bad things? So generative models have limitations, and one of the main limitations is that they are frozen in time. So they are limited to the time specifically where they have been trained, right? So there are techniques to basically, augment generative models and LLMs, et cetera, but in general, they're frozen in time, and they are not aware of your company's private data, because sometimes you have specific private data that you don't want to share, you don't want to expose private data to LLMs, et cetera, so they will never be aware of those of that information. Okay, so those are some of the limitations that we see. So key takeaways. So AI at Oracle, it has become very, very easy to interact with multiple OCI services when they start adding these GenAI capabilities, and we hope we can use for example everything that you saw with this digital this diagnostic assistance very soon in AHF. But in general, we saw that these systems are giving us the best return on investment, because we are investing on providing this sort of capabilities, and that investment is coming back to us in a huge way. So basically, we are adding a lot of value to the services by adding GenAI. We are very focused on security at every layer. So that's something that we specifically take a look at every time that we are implementing this type of systems. So security is of most importance to all of our customers, especially when we are dealing with data. So this is something that we have very, very close to us. And it's future enabled in the sense that these models are getting better and better and better. So these systems get better as they use other pluggable LLMs, or basically the same versions of the LLMs that have been improved over time. Okay, so I have a few links here. If you want to try out the chat ADB that I showed in that very quick demo, you can scan the first QR and you can go ahead in a very guided live lab and you can implement it by yourself, and you can start playing with it, and you can probably point it to another database, maybe your database with your data. And if you want to get started with autonomous, we have a lot of free versions there, and you can explore a lot of extra AI services in the third column. One piece of advice before we go, and thank you for being here with us, and thank you Arjun for being here with us. One piece of advice with SelectAI is, remember that we are creating a profile. So in that profile, we're passing metadata, and we're saying, oh, these are the tables, and the system is going to take a look at the columns inside the tables, and it's going to try to derive information. It will try to derive context. If your table is called X, and that's movies, and your column for total streams is called Y, and that's total streams, the system is going to struggle, right, in order to derive that kind of information. So make sure that when you are creating, these tables, these views, etc., and you're passing that to an LLM, make sure that things make sense, right? So the movies table, you might want to call it movies, right? That makes sense, a lot of sense. And the total streams column, you might want to call it total streams. It doesn't have to be exact, but it's good. The more metadata that you have there, the better that the system will perform. Okay, so that's just a note.
All righty. So if you like today's session, we hope to would love to invite you back to check out our other upcoming events. Also love to hear your feedback and what topic you'd like us to cover in the future. With that, I'll go ahead and close the session, and have a good day, and hope to see you soon at our future events.